So this lecture is on polymorphism. So what is polymorphism? It's just a way that you can assign derived class objects to base class references. It just means many forms, and we've actually already been using with polymorphism all along. We've been doing it when we use that is keyword. We've been doing it where we've been double clicking a button, getting that click event, and you notice that the button was actually being contained within the object base class. That's a form of polymorphism. We've done it in our examples where remember when we had vehicles, so I had like CLS my vehicle. This was of type, we say my, or we had, no, sorry, CLS vehicle of type my vehicle. And then what we could do is we could actually say my vehicle equals a new car. So we're actually able to write code like this. If you remember the other examples we wrote, we had a base class called vehicle. In that we had a derived class called car. And through polymorphism, what we can do is we can assign a derived class reference into a base class's object reference here. So this is the way polymorphism works. The same as you remember, like I just said, a button click, that button object can be held within the sender object. So the derived class can be treated as an object of its base class. However, a base class object cannot be treated as an object of its derived class. So again, the reverse is not going to be true here. So I couldn't create this car variable here and then put a vehicle into it. So this is where we talked about before on that is keyword, where remember I had like multiple I had a label and a button both sharing the same button clicked. We use the is keyword to do that, or we could do something like is CLS, my car or whatever. So we have is a vehicle, just to kind of give you some code here. I know that's misspelled, but whatever. So we're just saying, is my car, is that a vehicle? And that's where the is keyword comes in handy, and we can use that with polymorphism. So now what I want to do is I want to read you this sentence, and it's going to be kind of confusing. And so I'm going to read it multiple times as we go through this explanation, and I'm hoping it should start to make sense. And this was a sentence from the book, but I thought it described polymorphism really well. But again, it takes some explanation, so just bear with me. So C# determines which version of a method to call from which type of the object on which the method is called, not the type of the reference that refers to the object. Man, that is some crazy wording there, but it really does make a very specific point. So what it's saying is that, okay, you are going to have these derived classes from our base class. And each derived class is going to have its own individual method. Like before, remember we had that one that was like calculate salary or whatever it was from the book. And so each derived class that's more specific, this calculate salary is going to be more specific. So let's say we have an array of type employees. And inside this array, we can now create and hold derived class objects and put them into this base class array. So we've got an array of type employees. Then inside this array, we're going to instantiate a new, base plus commission employee and put it into our array. We're also going to instantiate, commission employee and put this into our array, etc., etc. And now we can loop through this array, and we can just call, dot, give me the salary, dot, give me the salary. And so that's going to actually call the method based on commission plus employee or just commission employee or salary employee. It's going to call that method that's specific. Remember that overridden method in the derived class? It's going to call which one is specific to that. So let me read this sentence again. C# determines which version of a method to call from the type of the object on which the method is called, not the type of the reference that refers to the object. So the reference that refers to the object is that base class employee, but it's actually going to call the method that's the type of the object, which is commission employee or base plus employee. So let's do another example here, and let's maybe just kind of comment a few things, and let's go with a video game example. And so maybe in a video game, let's do this is an outer space video game. So let's write some names of some classes here. So we may have a planet class, we may have a spaceship class, we have some, space gun We have a laser beam, laser beam kind of that we can shoot in space, things like that. We've got things like aliens and ships and all kinds of things in our little outer space game. Now, each of these classes are going to have their own unique method called draw. So inside of each of these classes, you're going to go ahead and write this method specific to what it means to draw a planet, draw a spaceship, draw a gun, etc., etc. So the planet doesn't know anything about these other objects, it just knows how to draw itself and knows the attributes about itself. So now what we can do is we can create, something like, our outer space collection. So we'll call this outer space collection array. So this is just an array that we can fill up with these types of objects. So we're going to instantiate this, and what we're going to do now is we're going to instantiate and put a planet object in it. We're going to put a spaceship object in it. And we're going to put, a space gun object also in it, etc., etc. And maybe we'll have lots of planets in this collection. We'll have lots of spaceships and lots of space guns. So we've got this array here. Now this spaceship collection array is of type space object. Okay, it is of type space object. Now all of these we're also going to inherit from the base class space object. So this is going to be our base class. And all of these are now going to inherit from our base class called space object. And inside this base class, it also has a method called draw that's meant to be overridden by these derived classes. So now we have our space object as our base class. We have these unique objects, planet, spaceship, etc., that have specific draw methods to them. We now created this outer space collection array, which is just an array of spaceship objects, and we're able to instantiate these classes and put objects of them because they're derived from this base class. So this is polymorphism now. So now in our code, we can do a for each statement and loop through this array. And we can say for each space object in my collection, right? So for each space object in my outer space collection array, and that space object here, we're going to say space object dot draw. Now this is the part of that sentence that we were just talking about before. So we're going to loop through, we're going to say for each space object in my outer space collection array. So when it says space object dot draw, the first time through the loop it's going to say planet dot draw. The next time through the loop it's going to be spaceship dot draw. Next time through the loop it's going to be space gun dot draw. Even though space object is of type space object here, this this my space object, it figures out what type of object is contained within it, and it calls the draw method specific to it. And that's how polymorphism can work. So let's go in now to a little bit more coding examples. So the first thing we could do is we can actually create what are called abstract base classes. So for instance, I could say public abstract class shape. Sorry. So now I've got this abstract base class called shape. Now the purpose of an abstract base class is only to be inherited from. It's kind of like a stub. You can never actually instantiate the shape base class because our logic is that it's not going to have enough code in it to be used by itself. It's just sort of a stub that other people are going to fill in. And so what we can also do is have abstract void draw, for instance. And so this is an abstract method that if you inherit from the shape base class, you are required to override this draw method. And you can have normal logic here and normal methods in here, and you would inherit from those. However, you can never say shape my shape equals a new shape, because an abstract base class can never be instantiated. So you do not provide the implementation for these abstract methods, and the derived classes must override them. So these are implicitly virtual. right? Because you have to override them, but you don't have to use the virtual keyword because they're abstract. So you would then derive classes of maybe circle, square, triangle, and then inside of those you would override the draw method and make those specific to those particular shapes. Now we've also got the sealed keyword, so which means if you use the sealed keyword here, you're actually explicitly saying I don't want anyone to inherit from my base class shape. So you could just change this to sealed. And the same things, you could also use the sealed method so that you can't override them in your derived class. So let's go ahead and close this down. Bring up this example from the book, figure 12.4. So this is a public abstract base class called employee. And so this employee base class, you'll notice, has some implementation here. We've got some public properties. We've got our constructor, and we've got a method here that's overriding the toString method from our base class, which is object, because we always get that for free. So we've created some implementation, and then, oh, by the way, we've created this earnings method, which doesn't make any sense because we only have types of employee. There's no such thing as just a generic employee. They have to be very specific types, like salaried employee, hourly employee, commission employees. So if someone creates this abstract base class that's never meant to be instantiated, it's only meant to be derived or inherited from with derived classes. So you have to implement this earnings class. So let's take a look at a salaried employee. So here's our salaried employee. It inherits from employee, so it gets all that functionality. However, we have to override this earnings statement. If you were to comment this out and try to run it, it's going to give you a compilation error because it forces you to override earnings. So now if we look at an hourly employee, inherits from the base class employee, that abstract base class, and then we make things unique to our hourly employee, but again, we are forced to override our earnings method to make it specific to our hourly employee. Now we also have a commission employee, and it's going to do the same thing, override earnings. Now here we have a base plus commission employee. So we had used this before, but you'll notice it inherits from commission employee, and in commission employee then inherits from employee. So you can see now we have multiple levels of inheritance going on here, that you're getting all that functionality essentially for free. So maybe someone else coded these other ones. So now we have base plus commission employee. So we've just sort of made it more specific now. And again, the same thing, we can override that earnings since we did the inheritance. And then over here, we can now instantiate the different types of employees. So we have a salaried employee, hourly employee, commission employee, base plus commission employee. So we just instantiate those. And then they're just calling the different earnings methods in those objects. So now here's polymorphism where it's coming in. So you'll notice I've instantiated an array of employee that can hold any employee derived class objects. So it's an array of employees here. And now, because this is our abstract base class, I can add all of these objects to this array because they are all derived from class employee. And so what we're guaranteed to have is that method that we created in all of these methods, namely earnings. Because it was abstract in that base class earnings, we're guaranteeing the compiler that that method is going to be there. So what we're doing here is we're saying, okay, let's loop through each of the current employees and employee. Now again, this is the base class. So in order to make it specific, we want to call those specific methods. We say, okay, is this current employee a base plus commission employee? If it is, then let's cast it to that so I can access its specific properties. And so you could do that for any of them. But however, you notice down here, we're just referring to this object calling earnings. And it's guaranteed to have this method because it was an abstract method in our base class. So let's move on to the next example. So in C#, it does not allow for multiple inheritance. Now what that means is that there is some functionality that is nice to get from multiple inheritance. And so C# came up with this idea of what are called interfaces to kind of bridge the gap on that functionality. And so what you can think of as an interface is just a contract with the compiler. So always just remember it that way. If I'm going to implement an interface, I'm signing a contract with the compiler that I will implement everything that that interface defines. So again, just remember, interface is a contract with a compiler. And if you just remember that, they're pretty easy to understand. So let's go through an example. So an example here, we've said public interface iPayable. And it's just sort of a mnemonic that Microsoft's come up with that always start interfaces with I, a capital I, and then the name of it here. And what this interface in this example is going to do is it's going to try to bring together objects that aren't necessarily related. So before we had this abstract base class of employees, so all the derived classes were related to each other. Well, interfaces are a way to sort of bring together, using polymorphism, classes that aren't specifically related to each other. So for instance, we've got an employee here, a salaried employee, and we also have an invoice. And so you'll see, so we're going to bring these together using interfaces, but they're not quite related, but we still want to use polymorphism. That's going to make more sense in just a second. So we've defined this interface called iPayable that has a getPaymentAmount method in it that returns a decimal. So you'll notice, again, there's no implementation here. So if you implement this interface, iPayable, it forces you to create getPaymentAmount in your class. So let's take a look at that. So here we go. We've got this employee base class, so just like we looked at before, and you'll notice that this base class implements iPayable. So it looks just like inheritance, except rather than saying I inherit from something, I'm saying I'm implementing this interface. Now, because I implemented this interface, I signed a contract with the compiler that I will implement this method in my class. So if I scroll down here, sure enough, here's getPaymentAmount. Now what they've done is, because this is an abstract base class and we're not actually going to put functionality in here, and it doesn't make sense to put it here, we're actually just going to put the abstract keyword on this particular method, which sort of just passes along this contract that says any derived classes, hey, I'm forcing you to implement it. But as far as this iPayable interface is concerned, this is enough implementation. You've signed the contract. You're good to go. So now let's take a look at salaried employee. So salaried employee inherits from employee, which has implemented that interface. So because of that, it forces us to override it, and here's getPaymentAmount right here. So it's forcing us to implement that interface. If we take a look at invoices now, this is a class that's completely separate from employees, but it's implemented iPayable. So that means if we scroll down here, we're guaranteed to have overridden getPaymentAmount, and you know, sure enough, they've implemented it here, and they've put the functionality here. So how does this tie? How are we tying all of these together? Well, this is how we can do it. So now in this console app that they're actually using it, you'll notice, just like with polymorphism before with the employee object array, here's an iPayable array. So what this is saying is create an array that's able to hold any object that is implemented iPayable. And so what it's done here is, you notice we've created two invoices and two salaried employees. And so you'll notice the invoice has nothing to do with salaried employee. But the way we're bringing them together is they all guaranteed to have getPaymentAmount. So it makes sense for employee to have getPaymentAmount, and it makes sense for an invoice to have getPaymentAmount. So what we can do now is, here's our for each statement. And so the var keyword just figures out the type for us. It's the same thing as saying iPayable. Let's just change that for right now. We're going to discuss the var keyword in another lecture. And so for each iPayable, current payable amount in payable objects, so this is the variable we're working with, and it's of type iPayable. And so now you'll notice we can just say getPaymentAmount. And through polymorphism, it can figure out the type of object that's contained in here and call that method or that object specific getPaymentAmount. And the reason this works is because it knows it's guaranteed. We've guaranteed the compiler that, because through signing a contract, that we're going to implement this interface by creating this method getPaymentAmount. So that's how it can do this right here. It doesn't even know what type of objects are inside here. It doesn't care. It just knows that it has to be able to contain this particular method. And that's interfaces and how they work together. So the next topic I want to talk about is the idea of operator overloading. Now you won't do this a lot, but it's kind of nice to know at least you can do that. And so in this particular example, what we're overloading, operator overloading, is the plus, minus, and you can see the multiplication operators. And so what this allows you to do is override, for instance, the plus operator to maybe add two objects. So think about what it means to add 5 plus 6. Well, the compiler knows what it means to add integer plus another integer. That makes sense to the compiler. It knows what a plus sign to two integers means. But let's go back to our other examples we've written before, like the vehicle class. Well, let's say we instantiate two objects, vehicle 1 and vehicle 2. Well, what would the compiler do if we said vehicle 1 plus vehicle 2? Well, that doesn't make any sense. So we actually need to define and tell the computer what the operator plus means for two types of vehicles. So in this particular instance, we've got a complex number which is made up of a real and imaginary. I know you're probably having, flashback nightmares of your math classes. But we've got this complex number now, and we're going to override the plus and minus operators, for instance. And so you'll notice that when we have the plus operators, we have two operands, right? The pre and post operands here. And so that's actually what gets passed in right here through this syntax. Might be a little easier to read if I do this. So this is the number on the left, and this is the number on the right of the plus sign that actually gets passed in when we create an operator overload. So operator overload, you have to make them static. This is the return type. So when we add two complex numbers together, it's going to return another complex number. This could be string, integer, anything you want, but it has to return a value. Then we say we're overloading the operator plus the left and right operands, do our work, and all it says is create a new complex number, and then it's adding in some of the parts of the complex number. And so when we actually use this over here, so we instantiate two complex numbers, x and y, and then what we can now do down here is you can see we can actually just add and subtract these. And so it makes sense if these were integers, right? However, these are actually of type complex number, and so now the compiler knows how to handle these. So the last example I want to go through is actually back to our vehicle example. And so you'll notice what I've done here is I've taken our vehicle and I've made it abstract. So since I've made it abstract, I believe that's the only thing I've really changed in here. Oh, I've also made this an abstract method here. So I've added in an abstract method, and I've made our class abstract for vehicle. So what that means is over here in my form, I had to comment out this code here because you can never instantiate a vehicle class now that it's been made abstract. So over to our car class, we're inheriting from our base class abstract, that is abstract. So that means we are forced to override that abstract method example. So we had to do this. And so if I were to come in here and comment this out and try to run it, it's actually going to give me an error. And it's going to tell me that, hey, you did not implement that abstract member. What you can also do is maybe you don't know which ones you need to override. You can come up here to your vehicle class, and you'll notice that it's actually going to allow me, let's see, okay, here. On my class, I can click this light bulb and it's going to say implement your abstract class. And so when I click that, you can see that it actually went ahead and put in the methods that I'm forcing to be overridden here. Like for instance, abstract method example. And it's nice because it puts all the syntax in there for you. The next thing I did was I just went ahead and instantiated created another class called truck, and it's inheriting from that base class vehicle. And again, because I did that, I had to override that abstract method example. When we come over to our code here, now at the bottom here, I'm creating an array of vehicles. I'm creating a car, a truck, and another car. And now because they're all derived from the base class vehicle, I can allow to put them all in this array. And then as I loop through this array, I'm guaranteed to have this abstract method example method in there. And so it's able to call that using polymorphism.